Good morning students. Today I am here with this video to discuss with you the passage based questions which are asked in IIT JEE Advanced. So our today's topic is Newton's laws of motion, particularly friction. Earlier I have posted a passage based question from the topic kinematics in my Facebook page at the rate the perfection classes contact. You can check it. I had taken this passage from Aryanth publication. You can check this, the passage 1, question number 48 to 52. In this question, it is asked that a man wants to slide down a block of mass m which is kept on a fixed inclined plane of inclination 30 degree. This is the inclination 30 degree given. This is the inclined plane. Here is the block of mass m. Now, in the passage, to just start sliding, the man pushes the block down with the incline with a force of F. That means here the block is not sliding. That means the frictional force acting here in this direction is sufficiently equal to the force this side. We will check this in the fluid diagram in the answer sheet. Now the block starts accelerating. When the man applied a force, the block slide accelerating. Okay. To move it downward with constant speed, the man starts pulling the block with same force. That means when the block is started sliding, the man again applied a same force F this side. Surfaces are such that the ratio of maximum static friction to kinetic friction is 2. That is mu s by mu k is 2. This implies that mu s equals to 2 mu k. Mu s is the coefficient of static friction and mu k is the coefficient of kinetic friction. Now some questions are asked. Before moving to the question, let us understand the situation very clearly. What is the situation? Situation here is that when the block is not sliding, the component of mg is this side, this mg gravity force is this side. So the two component of this, one is cos component, that is mg cos 30 degree will act perpendicular downward to the inclined plane, and mg sin 30 degree along the plane, and n is the normal reaction force of this surface. Now the frictional force will be mu n. Here this mu n is not reached its maximum, that is the limiting frictional force, because it is not sliding. That means the mg sin 30 degree and this mu n now are equal. Now to start the motion, a man has applied a force F. It said push, that means it is this side, the force will act this side. From this we conclude that what I have written, first I am reading out for you. The free body diagram, that is FBD, when the block of mass m is not sliding. You can check the FBD, mg sin 30 this side, mg cos 30 this side, and is this side. So and here n will be mg cos 30 degree and f is mu n. So f will be mu mg cos 30 degree. I have not written here mu k mu s because when we are going to the situation, we will check. In the first question, it is asked that what is the value of f. Options are given. Now to know this value of f, I have written as the block is not sliding. This means that the frictional force acting upward is less than f max, that is a limiting frictional force, which can be mu s mg cos 30 degree in this case. So when the man pushes the block, it starts sliding. That instant the frictional force will be mu s mg cos 30 degree. So for just starting acceleration for the block, that time frictional force will act as mu s mg cos 30 degree, that is the maximum limiting frictional force, and this side f is there, mg sin theta is there, and this side frictional force is there. So the sum of these two forces must be equals to this f. So I have written the equation as f plus mg sin 30 degree equals to f. From here we get f equals to mu s mg cos 30 degree minus mg sin 30 degree. We don't know the value of mu s, so we cannot get the value of frictional force for this applied force from here. For this we have to use the second case, that is the given that when the it is given when the now as this is accelerating, to stop this acceleration the man again applied a force F upwards, so that the body will become in dynamic equilibrium. What I have written now, when the motion starts, the frictional force will be F that is mu k mg cos 30 degree, and that will be less than the limiting frictional force, that is mu s mg cos 30 degree. So upon motion the body starts accelerating, and to stop that acceleration the man has again applied a force F upwards. Now check the free body diagram, mg sin 30 degree this side, mu k mg cos 30 degree this side, applied force F this side. As this body is in dynamic equilibrium, so there is no acceleration, so mg sin 30 degree equals to F plus mu k mg cos 30 degree. Now if to put the value of F from this equation to this equation, you will get this mu s plus mu k times mg cos 30 degree equals to 2 mg sin 30 degree. From this, putting the substituting the value of mu s, that is 2 mu k, we get the value of mu k first, that is 2 by 3 root 3. So mu s will be 2 times mu k, that is 4 by 3 root 3. We get the value of the answer of the second question, that is what is the value of mu s, that is the coefficient of static friction. So answer will be A, that is 4 by 3 root 3. Now putting this value of mu s in this equation number 2, we get the value of F as mg by 6. So the first two questions are solved. First answer 48 will be B, and second is 49 will be A. Now for the next three question, we can check what is the question number 50. If in 50 it is said that if the man continues to push the block by the force F, then what will be the acceleration? So when the man continues to apply that force, that we get in the first answer, that is mg by 6 this side, mg sin theta 30 degree, that is it will be this side. Now it will be mu k mg cos 30 degree, because the block is in motion, so it will be coefficient of kinetic friction will be there in place of mu, as they have taken the acceleration A. So what is the equation? Equation will be the net force, that this side force minus this side force will be equals to ma. So this is mg sin 30 degree plus mg by 6 minus this side force, that is mu k mg cos 30 degree equals to ma. So from there we get the value of A as g by 3, that is what is the option? Option number D. So question number 50 answer is D. Now move to the 51. What is in the asked in the 51? If the man wants to move the block up the incline, what minimum force is required to start the motion? This is similar to question number 1. Now the free body diagram will be, now the man is pulling upwards, so that the block has a tendency to go upwards, so the frictional force will act downward, and it will be mu s mg cos 30, because right now the body is not moving, it is tending to move. So and mg sin theta 30 degree will be this side. So to just start the motion, the minimum force required will be the sum of these two forces. By putting the values, you will easily get the value of as 7 mg by 6. So this will, the answer will be C. 51 will be C. Now move to the next question, that is 52. What minimum force required to move it up the incline with constant speed? Again it is similar to question number 50. So there is no acceleration, again the body is in dynamic equilibrium, only the direction of F is changed, so the frictional force's direction also changed. Now this side F, this side frictional force, now here it will be mu k, because it is in motion, so that's why. And the mg sin theta will be 30 degree will be this side, so F will be mu k mg cos 30 degree plus mg sin 30 degree, so it will be